Good day, everybody. Our topic of discussion is pH curve. A solution of an acid has a pH value. If pH value of solution is 1, it should be a strong acid. One example of a strong acid is hydrochloric acid. A solution of an alkali has a pH of more than 7. If pH of solution is above 11 or 12, it should be a strong alkali. One example of a strong alkali is sodium hydroxide solution. A solution with a pH of 7 is neutral. So an acid has a pH less than 7, an alkali has a pH more than 7, and a neutral solution, for example, like water, has a pH of 7. It is neutral. A pH meter is used to measure the pH of a solution. If we have to measure pH of a solution, we make use of a pH meter. A pH meter is made up of an electrode connected to a reader, pH reader. From the pH reader, we can obtain the pH of the solution when the electron is dipped inside the solution. When an alkali is added to an acid, the pH of the acid mixture increases from a lower pH value. For example, if the acid is a strong acid, pH will be around 1. It will increase to a greater pH value, greater than 12 or 13 if the strong alkali is sodium hydroxide. The variation of pH of a solution, an acid solution, when another solution, alkaline solution, is added, we obtain a pH curve. pH curve. So here you have in your titration flask an acid. To the acid sodium hydroxide from the burette is added. A pH meter is connected to the mixture. The electrode is inside the solution. There is a magnetic stirrer which slowly mixes the solution, the mixture, when the alkali is added. If we see pH equal to 1, we can conclude we are using a strong acid. If pH is equal to 7, we can come to the conclusion that it is a strong alkali. If we add an acid to an alkali, the pH will, if we add an alkali to an acid, the pH will increase. And the variation of pH during the addition, we obtain a pH curve. This is an example of a pH curve. pH here is 1, so it is a strong acid. pH is 13, so it is a strong alkali. Between the two curves, there is a long line, a vertical line, a straight line. There is only one vertical line, so the acid used is monobasic. It could be hydrochloric acid, it could be nitric acid. There is only one vertical line, so only one salt is formed. Between the two extremes, 3 and 11, center of the line, 3 plus 11, 14 divided by 2, 7. So end point pH is 7. At end point, the solution is neutral. And from this we obtain the end point. This is the end point. There is a sharp change of pH from 3 to 11. Long vertical line indicates you are adding an acid strong to an alkali which is strong. We say that the pH changes sharp from 3 to 11. There is a long vertical line, and from the vertical line we can come to the conclusion that we are using strong acid and strong alkali. The vertical line has a center. To calculate the center, we take 3 plus 11 divided by 2, we obtain 7. So pH 7, neutral at the end point. pH 7, end point, salt solution is neutral. When the salt solution is neutral, there is no hydrolysis of the salt. If there is one vertical line, the acid is monobasic. If there is one vertical line, one type of salt is formed, and the salt could be a normal salt. That is, it is not acidic salt, it is not a basic salt. The vertical line helps us to choose an indicator. The vertical line helps us to select an indicator, a good indicator, a suitable indicator. The pH range of some indicators are shown: methyl range, bromothymol blue, phenolphthalein. All these ranges are along the vertical line, so these are suitable indicators, and the ideal one is bromothymol blue. If you follow on the table here, you see the arrangement of apparatus used to follow the change in pH of the acid during the addition of the alkali, and we can read the pH of the solution mixture by the pH meter, from the pH meter. Here you see a stirrer which slowly, gradually mixes the solution. This is the pH curve. pH is 1, strong acid. 25 vertical line and point. Vertical line, one vertical line is strong acid, strong alkali. One vertical line, center 7 pH of mixture. One salt is formed. Monobasic acid is used. This is a strong acid, and here you have ranges for indicators. The ranges which parallel to the vertical axis, along the vertical axis, are indicators which are suitable for the titration. So we have here an analysis of a pH curve obtained from a strong acid and a strong alkali, obtained by adding an alkali, strong alkali, to a strong acid. This is a curve, and the curve is known as pH curve. Thank you very much for your attention. See you next time for another lesson.